All right, ladies and gentlemen, let's set up our Cornell notes. Today's date is either going to be 8/30 or the 31st of August. Our learning objective today, and you can simply write LO for learning objective, is we need to write equations from graphs and word problems. We need to write equations from graphs and word problems. So if I give you a graph, you need to be able to write the equation. If I give you a word problem, you need to be able to write the equation. Let's start with graphs. And let's just look at an example real quick, and let me just refresh your memory. So let's take this line right here. What we want to do is we want to identify some key features. We want to know what we're talking about. We want to make sure that we have the x-axis is horizontal. We want to make sure that the y-axis is vertical. Just want to make sure we're looking at our graph correctly. And then what we want to do is we want to be able to identify the y-intercept. The y-intercept's right here. The y-intercept equals 3, and that should be just a dash. Y-intercept is 3. And we want to figure out the slope. And we can pick any 2 points. So we've got one point that's on a grid, and we want to find another point where the line intersects the grid at an intersection point. So right here, and we could use that. We could use this one. We could use this one. Let me give you, like right here, this point right here on the line, does that intersect at a horizontal and vertical grid? That doesn't work, so we can't use that one. We could use this one. There's a horizontal and a vertical intersection of the grid. We can use that point. Now what we're going to do now is we want to figure out the rise and the run. So we want to go up. You can pick anywhere you want to go, any point you want to use. You're going to make a triangle. You're going to go up, you're going to go over. There's the rise, and there's the run. Not run. And I'm sure you remember from middle school, from 8th grade, M, from 6th grade, from 7th grade, M is the rise over run. The slope is rise over run. So how many did we go up? 1, 2, 3, 4. So that's plus 4 because we went up. And then how many did we go over? 1, 2, 3, 4, 5, 6, 7, 8. That was 8. Well, what direction did we go? Did we go in the positive direction or did we go in the negative direction? We went negative. So rise over run, there would be 4 over negative 8. And we always want to reduce this down as far as possible. Always reduce your slope, reduce your fraction, negative 1/2. So the slope here is negative 1/2. If the slope is negative 1/2 and the y-intercept, which is the same thing as b, is 3, then we can write an equation. Remember our slope-intercept form, y equals m times x plus b. Now we just put everything in the right spot. Y equals negative 1/2 x plus 3. That is our equation. Let's do one more example real quick. It's the same process over and over again. Let's do one example and then we'll take some notes, okay? So we know our x and y axis. This is the y axis, this is the x axis. We need to find the y-intercept, which is right here. So we can say b equals negative 6. Let me make sure we can see that. Then we need to find the slope. So we want to find an intersection point. We can use that one right there. And there's another one. You can use any 2 points you want. I'll use this one and this one. So those are the 2 points I'll use. Rise is positive 2. The run, 1, 2, 3. Negative 3 because it's going backwards, it's going to the left. Start at one point and go over. Go up and over. So the m, rise over run, 2 over negative 3. And that doesn't reduce any farther, so we just rewrite it. Negative 2/3 and negative 6. So y equals m times x plus b. Then we're just going to put everything in the right place. And so that's y equals, in fact, let's just change that. Remember, there's another way that we can write y in function notation, if we can say f of x, where this is the input, the whole output is the input. You put the input into the function to get the output. So function notation, f of x is the same thing as y, negative 2/3 x minus 6, and there is your equation. Now, let's put some notes to this. Let's figure out what we need to write down. Let's fill some stuff into our Cornell notes. Let's talk about process. Let's talk about things we need to know. Let me draw our left column. Just going to draw that down. So I'm going to put the notes here, and I'm going to put the things that we need to know and the things that we need to do right here on the left. So let's talk about what we need to know. So when we're talking about graphs, so equations from graphs, let's think about the steps that we just took. There was a process to what we just did. Process. Step 1. We need to be able to identify the independent variable. Identify the independent variable. Identify the independent variable. And from here on, guys, I am going to write IV for independent variable because this is long. This is short. I like IV. Step number 2. We want to identify the dependent variable. And I'm going to write dv for dependent variable. So that's what we did. That's what we did right here. We talked about the axes. Which one we have to make sure that we know what we're talking about. So x-axis, y-axis, that's what we did first. Step number 3 was to determine the y-intercept, which is your b in the equation. And that was the next thing that we did. We figured out that it was 3. Then when we did this one down here, we saw there was negative 6. Step number 4. I'm going to include step number 4. We didn't do it particularly on this example, but I'll show you in just a second. It is something that we need to know. It is something that we need to be able to figure out. We need to determine. We need to figure out. We need to be able to identify. We need to determine the x-intercept. And sometimes this is called the 0. Let's take a look at this graph and figure this out. Where does this line hit the x-axis? It hits it right here. What's the coordinates of this? 6, 0. So a 0 is always going to have some number, 0. A y-intercept is always going to have 0, some number. And they're backwards, and it gets a little confusing sometimes. But we have to know the difference between a y-intercept and a 0. Zeros become important later on in the class, and we need to know both the y-intercept and the 0. And then step number 5 was the next thing we did. After we found the y-intercept, we figured out the slope. Choose any 2 points . Choose any 2 points of the line that intersect on the grid, that are on the intersection of the grid, that lie on a grid intersection. Remember, we picked this point right here because it's on the horizontal and vertical grid. This point won't work. This part of the line won't work because there's no horizontal grid marker. There's just a vertical grid marker. So we have to be careful to use the right points to make sure that our numbers are nice and whole numbers. We like whole numbers. After we figure out 2 points, then we can use those 2 points, step number 6, to determine to determine the slope, to determine m, which is the rise over run. Remember, folks, what we talked about is direction. When we count rise, we count the number of spaces it goes up or down, left or right. So when we're talking about the rise, going up is positive, going down is negative. When we talk about the run, going to the left is negative and going to the right is positive. And if we don't get our signs right, then we end up making an error. Even though we get the right fraction or we get the right number, if our signs are wrong, then the entire slope is wrong. All right, so those are the 6 steps. Oh, I'm sorry, there's one more step. There's one more step that we did. Once we figured out all the information, once we figured out the slope, and the y-intercept, the next thing we did was we just put everything in the right spot. We just actually wrote the equation. So the last step, step 7, is to put everything in the right place. So we have y equals m times x plus b, and then you put everything in the right place. Now, there's some things that we need to know. What are the things that we need to know from the example so far? We need to know IV, dV, and we need to know the y-intercept. We need to know 0. We need to know the rate of change. And we need to know all the synonyms for all of these words. Rate of change is rise over run, it's m, it's slope. The y-intercept is b, it's the starting value, it's the initial value. The independent variable is the input, it's the domain, it's the cause. We need to know all the different synonyms. And then we have a process. The process, there's 2 things that we need to be able to do. We need to be able to make sure that we know how to find the slope. And then the second process is, how do you actually write the equation? How do you write slope intercept form? And in fact, I'm going to add this up here. Up here, you need to know slope intercept form. You need to know that slope-intercept form is y equals mx plus b. These two are the same thing. Slope-intercept form, y equals mx plus b, same thing. Let's look at one more example real quick of this process. So if we look at this problem, the actual problem states, let me move this over, what does the slope of the graph represent? So in order for us to understand this graph, we need to be able to interpret it and figure out the slope, and sometimes it's also helpful to be able to write the equation for it. So let's actually write the equation for this line. First thing we did was we talked about finding, step 1, figure out what the independent variable is. It's hours, it's time. So the independent variable, time. The dependent variable, money. The y-intercept, which is the b value, is 0. And then the slope, m, is rise over run. Well, let's find another point. There's one point right here. We need to find 2 points. 2 points. There's one right there. And just in case you can't see it, you can always use the point that's given to you. Let's always use the point. If there's a point that's given to you, always use this one. Let's do the rise over run. Rise over run. How many did I go up? I went up, so it's positive, and I went up 320. I ran, I went from here to here, and that's 40, and it was to the right, so that's positive. So rise, 320 over 40 equals 8. What does this 8 represent? It's 8 what? $8 per hour. $8 per hour. $8 per hour. And as we look at First off, let's write the equation. So if we have f of h, because that's my input, equals 8h, because that's my input, plus the y-intercept, which is 0. So really, the equation can be shortened down to f of h equals 8h. What does the slope of this graph represent? It represents the number of hours it took. No, the slope isn't hours, so that doesn't work. The amount of money earned per hour. Oh, money per hour, dollars per hour. Yeah, that's right. That's the right answer. All right. Now, that's the process for a graph. Let's talk about the process for an equation. I'm sorry, for a word problem. It's a little bit shorter. There's a couple of things we need to figure out. So let's look at an example. Let's figure out how this is going to work. See if I can make all of this fit on the page here. An architect is designing an office building with N floors that have an FM radio antenna that is 15.85 meters tall on its roof. Each floor of the building will be 3.9 meters high. What function can be used to find the total height of the building in meters, including the FM antenna? All right, so there's a couple of things we need to do. Let's think this through for a second. So if we look at our examples, our answer choices, all of these are the same. So that's got to be the output. That's the dependent variable. The dependent variable. Here's our variable in the equation, so we know that that's the input. That's the independent variable, IV. But now we got to figure out what the numbers mean. We got to figure out what the numbers mean. So we know that we're looking for y equals m times x plus b. We know that b, not 6. We know that b is the initial value. So we know that these two have to be numbers. This one has to be a number, this one has to be a number. What are the two numbers in the problem? Well, we got 15.85 and we've got 3.9. So we got 3.9 and 15.85. Now, what number are we starting at? What number do we start at? Or what's changing? The building, the height of the building changes depending on the number of floors in the building. Is the height of the antenna ever going to change? No. Is the antenna going to be on the building? Yes. So this is where we start. This is B. And then let's read this sentence right here. So this is 3.9 meters high. Each floor of the building is 3.9 meters high. So if there's 2 floors, that's 3.9 times 2. If there's 3 floors, that's 3.9 times 3. If there's 5 floors, then that's 3.9 times 5. So this 3.9 is getting multiplied by the number of floors. So we can write this down. So that's going to stay the same. This is going to be plus 15.85 because it's already there. It's growing. It's tall. We need to add the antenna, including the antenna. Add the antenna to the building. So that would be 3.9 times n plus 15.85. And the answer is B. Wow. Okay. So there's a lot of stuff going on there. Let's see if we can break that down into smaller bits and smaller pieces. So when we're writing, let me put my columns in. When we're writing an equation from a word problem, there's 4 basic steps that we need to follow. So when we're writing equation, EQ, equation, no. Did that backwards. See, Valdez makes mistakes all the time. Erase that out. We're starting with a word problem, and we have to write the equation. EQ for equation, WP for word problem. Starting with a word problem, having to write equation. 4 basic things we need to do. First, we need to identify the independent variable. Once we figure out what the input is, then we need to figure out what the output is. We need to identify the dependent variable. And a couple of things that you can use to do this. So once we figure out what's changing, we know that the independent variable determines the dependent variable. Or to flip that around, we know that the dependent variable depends on the independent variable. So in our example right here with the floors and the height, do the number of floors determine the height, or does the height determine the number of floors? Well, you'd have floors first, and then you could measure the total height. Or we can say it this way. Does the total height depend on the number of floors, or does the number of floors depend on the total height? The total height of the building is going to depend on the number of floors. Height depends on floors. Height is your y, n is your x. Okay, that's the way that kind of works. The third thing that we need to do is we need to determine what the numbers represent. Because there's always going to be numbers in the problem. We need to know what the numbers mean. Determine what the numbers mean. And here are your options. The numbers, there can be a rate of change. It can be the y-intercept. So this would be the m. This would be the b. Sometimes the numbers in the problem, it'll be some kind of 0. It'll represent the x-intercept. And sometimes there'll be numbers in the problem that represent points. It'll represent x, y coordinates. Those are the 4 basic options. Now let me give you some hints as to figure out what numbers are what. So right here for the slope, there are key words for m. Per, each, every, a. Those keywords, per, each, every, a. These keywords help you figure out m. So if you see one of these 4 keywords, per, each, every, a, you know that that number is going to be related to the slope. So right here, let's look at the sentence. It's 3.9. Look how the sentence starts out. Each floor of the building will be 3.9. Each 3.9. 3.9 was the slope. Per, each, every, a. So if you can find per, each, every, a in the problem, you know that whatever number is associated with these keywords is going to be the slope. The b value, this is going to be, the idea that you're looking for here is the starting point. Where does it start? This will also be the initial value, another way to think about that. What's the number that it starts with? What's the value it starts with? What do we start with? What's the initial value? That's your b. So once we figure out and once we can identify the numbers, we've identified the x and the y, we've identified the input and the output, we've identified what the numbers represent, then we can just, step number 4 is to put everything in the right place. Put the parts into the equation. Because the equation is f of x equals m times x plus b. Or the way that you learned it in middle school, y equals m times x plus b. This is the dependent variable. Oh, sorry. This is the dependent variable. This is the rate of change. This is the independent variable. And this is the starting point. And once we identify it up here, we just put the 4 bits in the right spot. Let's take a look at an example real quick. Promise we're almost done. Let's see if I can make this all fit. Airline passengers pay $439 to fly to California. For this price, customers may check 2 pieces of luggage. There is a fee of $25 for each additional piece of luggage a passenger wants to check. Which function can be used to find the amount of dollars a passenger has to fly with P pieces of luggage, where P is greater than or equal to 2? Let's look at this for a second. So the first part of the process, first thing I told us to do is we needed to identify the independent variable and the dependent variable. The independent variable and the dependent variable. Let's look at our answer choices. There's a P and a C, a P and a C, a P and a C, a P and a C. All right, so what's the output? What is the dependent variable? Is C. What do you think C stands for? What part of this problem is C? What would C stand for? What are we trying to figure out? Which function can be used to define the amount in dollars? So C represents dollars, C represents cost. All right, so, and then we're looking for P. P has to be the independent variable. What does P stand for? It tells us right here. P is the pieces of luggage. So we know that P is the luggage. Now we just got to figure out what the numbers mean. Now if we look at the equations, the answer choices here, we've got a 439, we've got a 25, and we got a 2. Are there any keywords? Are there any keywords? Per, each, every A. Per, each, every A. Is that anywhere in here? Per, each, every A. Per, each, every A. Ding, 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 ding. Each. Each goes with 25. 25 is your M value. All right. And that kind of makes sense because as we look at these answer choices, 25, 25, 25, 25, they're all connected to the X, which kind of makes sense. Y equals, oh, let me move this down. Y equals, sorry for the shaky. Y equals M times X plus B. M is 25, C and P, which makes 439, the initial value. As it starts, you have to pay $439. You have to pay $439 in order to fly. So that's the initial value. And then the total price is determined by how many bags you check. Let's figure out, so if this is B, what's happening with this bad boy right here? What does this mean? Because there's no P, there's no 2 here, there's a 2, no 2, and then a 2. What does this 2 mean? It says that you get 2 pieces of luggage for free. You may check them in for free, and that you pay $25 for each additional piece of luggage. So let's think about this. If you check 1 bag, do you pay money for it? No, you get it free. So do you pay $25? No, that doesn't make any sense. If you check 2 bags, do you pay $25 for each one? No, because it says you can get 2 bags for free. You can check 2 bags for free. Each additional costs $25. So if I check 3 bags, am I paying $25 for this one? No. Am I paying $25 for this one? No. Am I paying $25 for this one? Yes. Okay. So how many times am I paying $25? 1 time. So how many bags I have? 3 in this case right here. 3 minus the 2 free. How many am I actually paying for? $25. I'm paying that 1 time. So if I have 3 bags, I need to subtract 2 in order to get the right amount that I pay. If I check 5 bags, where are my 5 fingers? If I check 5 bags, I get 2 of them free, which means I have to pay for 3. 25, 25, 25. So 25 times 3. 25 times P, 5 minus 2. 5 P minus 2. The correct answer for this one is C. So ladies and gentlemen, if we follow the process and do a bit of thinking, we'll be able to write equations from graphs and from word problems. Now, there's a couple of things. Let me just solidify. Let's just make sure we're all on the same page. What are the things that we need to know, and what are the things that we have to be able to do? So in this process of being able to write equations from word problems, the things that we need to know is very similar to what we've already talked about. We need to know IV, we need to know dV, we need to know rate of change, we need to know y-intercept, we need to know our slope keywords, per, each, every, a. We need to know slope-intercept form. We need to know what the phrase slope-intercept form means, so that when I say slope-intercept form, you know, oh, slope-intercept form, that's y equals mx plus b. I know that already from middle school. I just might not have known that it's called slope-intercept form. And then the process, there's a process that we need to know. There's some steps that we need to know. We need to know the 4 steps right here of how to write an equation. From a word problem. And that'll do it.